Okay, so today's lesson is called Solving One-Step Equations. You learned how to solve one-step equations in 6th grade, as I talked to your teacher the other day, and he said that you did. So you all should have done this in 6th grade. So it's basically a review lesson today. We are only going to spend really a day. We'll be working a little bit more with one-step equations tomorrow, and then when you come back from the break, we'll be into two-step equations, which is the standard for 7th grade to be able to solve two-step equations. So our objectives are to solve one-step equations by subtraction, then by addition, then by division, then by multiplication. So we're going to hit them all in one day. Okay, to solve equations, you use inverse operations. In case you're a little fuzzy about what an inverse operation is, I put this in other words. Do the opposite. To undo the operation that is already there. So if you had addition, you would do the opposite, which is subtraction. If you had subtraction, you would do the opposite, which is addition. If you had multiplication, you would do the opposite, which is division. And then, of course, division's opposite would be multiplication. Now, I have to tell you that most of you are going to be able to look at a lot of these one-step equations and say, oh, the answer is this. Because one-step equations are easy, and they're easy to look at and figure out the answer a lot of times. However, I want you to show all of your work. The reason for that is when we do two-step equations, it's a little harder to do it in your head. When you do multi-step equations, those are nearly impossible to do in your head. I have done algebraic equations or really complicated later on in math problems like calculus that use algebra that take an entire page of calculations to do. So you have to be proficient at showing your work on paper. Otherwise, those kinds of problems will be completely out of your reach. Okay, so let's move on to our first one. It says to solve one-step equations by subtraction. All of these equations show addition. We're going to be doing the opposite, which is subtraction, in order to solve them. So here's the work that I want you to show. We're going to do the opposite of adding 3. We're going to be subtracting 3. When you do something to one side of an equation, you have to do it to the other side. It's like you have a balance. You know, one of those little scales. You may have had them, I don't know if you had them in kindergarten where you had little teddy bears, little plastic bears. Did you ever have those little plastic counting bears and you can put so many on one side and so many on the other side? That was my favorite part of doing kindergarten lessons, was playing with those balances. So anyhow, when you have an equation, if this says plus 3 and you take away 3 from that side, it's going to make that side lighter, it's going to make it go up, right? So you have to take away 3 from the other side, and then it's still balanced. You will deal with this issue of balancing equations someday when you do chemistry. You have to balance equations. You have to have the same number of elements, atoms, I don't really remember, on each side. So you will have to deal with this. This equal sign means that both sides are equal. So whatever we do to one side, we do to another. When we do 3 minus 3, we get 0. So all that's left on this side now is x. We had an x plus 3. We took away 3, so we're just left with x. 8 minus 3 is 5. That was a lot of explanation for something that you could have looked at and said, something plus 3 is 8. It must be 5. But this is the work that I want you to show. Ross?
Couldn't you also define the answer, do the answer minus the only number that you have in there, like 8 minus 3, to get the answer too?
Yeah, that's what we did,
Okay.
but technically we're doing it to both sides. That's why it disappears from that side. So I want you to show it on both sides when you do it. Okay, the next one we have x plus 4 equals 10, so I'm going to subtract 4 from both sides, and I get x equals 6. Okay, the next one. Irene, tell me what I would do.
You would do minus 14 to the 14, and then you would do minus 14 to the 25, and you would get a equals 11.
Good. Let's just go over the you try ones together because they're not all that difficult, and it'll be a little quicker if we just go over them together. Carly, tell me how to do the next one.
You 5 minus 9, 1 minus 9, and 17 minus 5 on the other side. get b equals 12.
Good. If you want to, you can just say you would subtract 5 from both sides. You can express it that way. Read, next one.
You do minus 6 to the 6, and then just put x to the 0, and then do minus 6 to the 23, and then you get 17.
Okay.
So x equals 23.
And the last one, Eli.
You would do minus 10 to the 10 and 38.
Okay, so F equals,
28.
good. Okay, any questions about those? Okay. I have some more examples on the next page. There are some slightly different looking problems. This one has the 3 first instead of the x. Because the 3 is positive, you would do the same thing to get rid of it. You would need to subtract. It doesn't matter what the sign is in between the 3 and the x. What matters is what's in front of the 3, which in this case is nothing, so we know it's positive. So we're still going to subtract 3 from both sides, and x equals 15. And remember, because of the commutative property of addition, we could also have just flipped that around and written it as x plus 3 equals 18, and it would be the same thing. The next one has a negative number on one side, which is something you certainly did not encounter in 6th grade. So when I subtract 15 from both sides, I have m equals, I have 2 numbers with the same sign, so what do I do to those numbers? I add them and keep the sign, so it's negative 25. And then the last one is another example with a negative number. Subtracting 7 from both sides gives me g equals negative 16. Dakota, tell me what to do for the next one.
Subtract 6 from 6 and 40.
Okay? And I end up with?
Y equals 14.
Good. Y equals 14. Okay, next one, Riley.
Minus 13.
Okay, and what do I end up with?
H equals negative 17.
Good. Jake, last one.
X equals negative 33.
Tell me what to do.
You put minus 9 under the 9, and then minus 9 under the negative 20.
Okay, good. So x equals, what did you say?
Negative 33.
Good. Okay, any questions about any of these? Okay, next we're going to solve two-step equations by addition. So these ones show subtraction. To undo subtraction, we add. So we add 5, again, to both sides.
That looks like a division.
I know, it didn't.
You kind of got rid of part of my previous. That's okay. I know.
We all know what it is, right? Okay. All right, next one. I'm going to have you guys do these from the start. Helena.
Add 4 to 470.
Okay, and what do you get?
21.
Good. Next one, Jimmy. This one's a little bit different because we have addition in between the numbers. But what do you need to do, Jimmy, to get rid of that negative 23? You have to add. Yeah, we don't have to switch it up here, but what we do have to do is add 23 to both sides, because negative 23 plus 23 will get rid of the 23. So x will equal what, Jimmy? Good. Eve, next one.
You add 8, and then you add
Okay, and then x equals?
29.
Okay, Grace, next one.
You add 14 to 14, 14 to 12, and x equals 26.
Good. And the last one, Reagan.
You would add 34 to 34 and 13.
Okay, so x equals
47.
good. Okay, any questions about these? Okay. Some more examples, these ones involving different kinds of signs and different kinds of things you may encounter. Ross, first one.
You would add 9 to negative 9, and then you would add 9 to 11 to get x equals 16.
No, careful, the signs are different. What are we doing? The signs are different. Same signs, add and keep. Different signs.
Subtract.
Subtract. Yeah, when the signs are different, we have to subtract and keep the sign of a larger number. So what would we actually have? 2. X equals 2. Sky, next one.
You add 6 to 7 on both sides.
And end up with?
138.
Careful, Sky, different signs. What do we do? We have a negative 71 and a positive 67.
Oh, so negative.
The answer is going to be negative. Negative what?
138.
No, if the signs are different,
Subtract.
yeah, we have to subtract. So if we subtract, what do we get? Keep the sign of a larger number. Yeah, so these integer rules that we learned in the last unit do not go away. Now we have to apply them when we're solving equations. Kaylin, next one. And what do we get? Good. We got the different signs subtract. That was sign of a larger number, so they were exact. Violet, next one.
Add 8 to 8 and add 8 to negative 17.
Okay, so x equals?
You should do x equals.
Good, negative 9. Signs are different, so we subtract. We keep the sign of the larger number, which is the negative 17. Adria, next one.
I got x equals negative 39.
Okay, tell me how you got that.
Add 25, 8, and then you subtract.
Okay, subtract and get, what did you say you got again?
Negative 38.
Negative 38, good. Okay, next one, Michaela.
You add 18 to both sides and get 11.
Good. X equals 11. Okay, any questions about these? Yeah, notice a couple Chromebooks open. Please close your Chromebooks. Okay, third objective is solving equations by division. So remember, a number right next to a variable means multiplication. So in order to undo multiplication, we divide. When you show your work for division, do not use the little division sign that looks like the minus sign with 2 dots. We never use that in algebra. What you do to show your work is draw a line and show that you're dividing 3 from this side, also dividing 3 from that side. So when you do that, 3 divided by 3 is 1, so we're left with 1x equals 9 divided by 3, which is 3.
Want us to write 1x or just x?
No, just x, yeah. Writing 1x is kind of a superfluous thing, meaning it's not necessary. I'm not going to mark it wrong if you write 1x, but I would prefer that you don't. It's not standard. Okay, Taryn, try the next one.
You would have to do divide by negative 2 on both sides.
Okay,
And
and you get what?
negative 4.
X equals negative 4. Good, you have to remember your multiplication rule that when you multiply different signs, the answer is negative. Zoe, next one.
You might put 5 under negative 5x and then
Like that?
the other one.
Like that?
Negative 5.
-5, thank you. Okay,
X equals 5.
good. X equals +5. When we divide different signs, multiply or divide different, or I'm sorry, multiply or divide same signs, we get a positive answer. McKenna, next one.
You would do 6x divided by 6 and 36 divided by 6 and x equals 6.
Good. Next one, Pat.
You do, you put a 10 you put a line under -10 and then put just normal 10. And then put another line and then 10 underneath that. And it would be,
Okay, wait a second. I'm going to stop you for just a second. I want you to look at the top 2 examples of what we did there.
oh, negative.
Negative. Yeah, you have to include the negative sign. Otherwise, your answer will say negative x
Yeah.
equals something, and we need it to be positive. Okay, so x equals,
It would be x equals 10 or -10.
-10. Good. Okay, last one, Brayden.
I did, you take -9
Mhm.
under 9.
Okay.
And you get x, and put -9 under 72, and you get 8.
Good. Okay, any questions about this slide? Okay, one more. We're in the home stretch. To solve equations by multiplication. So x, my fraction lines disappear a lot of times. X over 3 means x divided by 3. To solve division, we do the opposite, which is multiplication. When you're showing multiplication, I want you to show it with a dot. And make sure you write your number that you're multiplying by up beside the numerator of your fraction. You're multiplying the whole thing by 3, which is 3 over 1. And you don't have to write the over 1 part, but it's not correct to write it down on the bottom. It looks wrong.
Right, 3 over x.
No, no, no. You're not multiplying by 3 over x. If you multiplied 3 over x times x over 3, everything would cancel out and you'd have 1 equals something, and that wouldn't be true.
Oh, I thought it's supposed to cancel out.
No, the x can't cancel out. We want to keep the x. What we want to cancel out are the 3's. So if this were 3 over 1 and we were multiplying this fraction, this would cross simplify to 1's, and then this would be 1x over 1, which is just 1x. 14 times 3 then is 42. If we did what you suggested, I'm going to do this. Don't write this down, but if I did x over 3 times 3 over x, I would have to multiply the other side times 3 over x. Then I would end up with 1 equals 42 over x. I don't want that. That's messier than what I started with.
It would just be x would be 42, right?
Yeah.
You still get the answer.
Well, kind of, but then you have to multiply both sides by x to get x back up here. Okay. Elena?
Did you make like 14 and 3 and do like put the x underneath the 14 and then do the multiplication? Do you want to?
No, I do not. She's talking about could you do this?
Yeah.
Right. No, I don't want you to do that.
Okay.
Because anytime we use x's, when you have a long page of work and you've got x's in there that don't mean x, that mean multiplication, it's very confusing. Okay, next one. We're going to multiply by -5 because what we're dividing by is negative. So you show that again by writing it up by the numerator. So the -5's cross out diagonally and x equals positive 15. I'm going to have some of you actually come up to do these because I want to make sure you're putting the multiplication in the right place, because that's a mistake I see a lot, and then people get confused and they multiply the wrong part in more complicated problems. So volunteer to come up and do the next one. Violet, come on. Who wants to go next so we can be ready? Grace, your hand was up first next. So come on up, Grace, you can be ready.
It's just a little hard, right?
You know what? Why don't you let Grace do, no, stay here. Let Grace do that one and you do the one that's a little lower down.
Okay. It's kind of hard to do.
Yeah, it's easy. You have your bandaged finger and you're not very tall, so. Very good. And pass the pen to Violet. Who wants to volunteer for the next one? Irene, are you already volunteering?
Yeah.
Yeah, come on up. You're having the same problem I have. Sometimes it doesn't want to write. When you write with this pen, you have to write straight on. Don't slant it at all like you would when you write on paper.
It's kind of difficult for her.
I know, it's difficult for her because she is. There, she did it. She did a good job.
Okay.
Hit the back button. Okay. There you go.
You don't like it.
Good. That says negative 36. Just to make sure you can see it. Irene, next one.
Okay.
Rating. I'll do the last one.
It writes higher than you expect it to.
Guys, don't talk. Oh, careful. 9 times 6 is not 56.
Or 50.
Yeah, use the back button there.
The other 56, right?
All right, there you go. All right, one more. Are there any questions about anything we've done up here so far? Okay. It's supposed to be easy. Yeah, this isn't, guys, it's not, this is a super easy lesson, but it's important for me to know that you all have the right foundation with 1 step, so that when we move on to 2 steps, you're all showing your work properly and doing the right thing. Close. Negative times a positive is?
I put that on my phone.
Yeah. All right. Good job. Any questions before we do the exit ticket? Okay.
Yeah. He has a negative.
Yeah, he did put it.
Negative.
It's there. It's there.